And second one is Faraday's second law. Faraday's second law states that now I am taking here different electrolytes. When the same quantity of electricity is allowed to pass through the different electrolytes, which is connected in a series manner, when the same quantity, for example, if you take NaCl solution, AgNO3 solution, copper sulfate solution, different electrolytes in a electrolytic container cell. Okay, this is anode, cathode, anode, cathode, anode, cathode. When the same quantity, of current, when the same quantity of current passed through or electricity is passed through different electrolytes, connected in series, the weights of the substance deposited electrode, that means the weight of the substance, here sodium is deposited, here silver is deposited, here copper is deposited. The weights of the substance deposited at the electrode is proportional to the directly proportional to the equivalent weight, E is called their chemical equivalence weight. That means here W is directly proportional to E. If you take W1 is directly proportional to E1, W2 is equal to E2, E1 by E2 ratio is equal to W1 by W2 ratio is equal to E1 by E2 ratio. That means we can conclude that here weight of the sodium means weight of sodium by equivalent weight of sodium. Weight of sodium by weight of sodium, weight of silver by equivalent weight of silver, weight of copper by equivalent weight of copper. This is a statement and mathematical expression. The amount of substance deposited by passing of 1 Faraday charge through an electrolyte is equal to gram equivalent weight. 1 Coulomb charge is equal to 1 equivalent weight. That means here that is equal to the amount of substance deposited by passing of one Faraday charge. One Faraday charge is equal to one equivalent weight. The amount of substance deposited at electrode, the amount of substance deposited by passing of one Faraday charge through an electrolyte is equal to the gram equivalent weight. That is equal to E. E means equivalent weight, gram equivalent weight. That is equal to E is equal to capital E is equal to, or if you take weight is equal to W is equal to E into F gram equivalent weight here. Capital E is equal to E into F, where E is equal to E by F is equal to small e, that is electrochemical equivalent. By applying our first law here, W is equal to ZE Q, where Z is nothing but here, E by F into IT. Already you know what is E, M by N, F into IT by 96,500. That is equal to first law of Faraday's law, mass. The mass is deposited electrode. In case here you take atoms, atomic weight by valency also. Atomic weight by valency. So if you take a gas for gaseous reaction, VE. VE means here equivalent to volume of the gas liberated. Equivalent volume of the gas. Here formula V is equal to VE into IT by 96,500 coulomb. This is the volume of the gas liberated at electrode, where Vs is the equivalent volume of the gas liberated. What is the equivalent volume, sir? The volume of gas liberated electrode at STP by passing of one Faraday charge. The volume of gas, what is Vs, sir? The volume of gas liberated at electrode at STP standard temperature and pressure. Standard temperature is 0 degrees Celsius at 273 Kelvin. Standard pressure is 1 atm. By passing of one Faraday is called equivalent volume of gas. This is equivalent volume of gas. Finally, here how to calculate the equivalent mass here, equivalent volume, sir. For example, now I am taking here some gases like hydrogen, and if you take some gases, chlorine, 2H plus ions gains electrons to form H2. Or if you take 1H plus ion, 1 H. If you take these 2 electrons is equal to 1 mole of hydrogen gas, or 1 molecule of hydrogen. Here 2 Faraday is equal to 1 mole of any gas occupies 22.4 liter volume. Here 1 Faraday is equal to 11.2 liter. And if you take one more, 2 Cl minus ion, try to lose 2 electron to form Cl2 gas. Okay, 2 electron is nothing but 1 mole of chlorine gas. Okay, that is 2 Faraday is equal to 22.4 liters. 1 Faraday is equal to 11.2 liters. thickness of coated layer and current efficiency. Thickness. Thickness of coated layer and current efficiency. Thickness coating means, you can observe here, let the dimensions of the metal sheet to be coated, dimensions, A centimeter, B centimeter. Let the dimensions of metal sheet to be coated, A centimeter, B centimeter. The thickness coated layer is equal to, thickness now I am taking here C centimeter. This is thickness coated sheet. First one is the metal sheet dimensions I am taking. The volume of coated layer is equal to, multiply volume of coated layer is equal to, multiply all the terms, A into B into C centimeter cube. The mass deposited substance. The mass deposited substance. Now I want mass here. The mass deposited of a substance. Okay, what is the mass formula here? Volume into density. Volume into density. Okay, volume already in ABC, density D. A into B into C into D. That is equal to mass deposited. Finally, the mass deposit of the substance at electrode A into B into C into D is equal to I into T by 96,500 coulombs into E. What is current efficiency, sir? Current efficiency or sometimes the ammeter shows false current due to mechanical fault. From thermodynamics we know that no system is 100% efficient. So in an electrochemical system, this efficiency is determined quantitatively by current efficiency as follows. Current efficiency formula you can observe here. Current efficiency, the percentage of current efficiency is equal to actual current or charge actually used in electricity, charge actually used in electricity by charge passed theoretically. Charge passed theoretically into 100, one formula, or percentage of current efficiency is equal to mass actually produced by mass that should have been produced in 100, or actual current by simply mass actually produced by mass that should have been mass should have been produced into 100. And one more formula here, percentage of current efficiency is equal to actual current by ammeter current into 100. This is the formula, actual current by ammeter current into 100. Okay, this is information about remaining concepts. Thank you.